Another important way that we can get a new function from, in this case, two old functions, or maybe just one old function, is called composition of functions, where you're putting one function inside of another. Now, we're not going to try to understand how the graphs of these work. That's extremely complicated. What we do want to understand is just how we actually do this. So suppose we have a function f of x is x squared and g of x is x plus 3. We'd like to find a formula for these two new functions, f of g of x and g of f of x. So what is f of g of x? Well, when we learned our order of operations, we start from the inside parentheses, the innermost parentheses. So g of x we know is x plus 3. So this is really saying f of x plus 3. Now what is f's job? F's job is that whatever you feed f, it squares it. So in this case, it's supposed to be x plus 3 quantity squared. So that's what f of g of x is. Now let's see if we reverse the order if we get the same thing. G of f of x, again, we start from the inside. F of x is x squared. So this is just saying g of x squared. And what is g's job? G's job is that whatever you feed g, g adds 3 to it. So if you feed g x squared, the output will be x squared plus 3. So did we get the same function for f of g of x as for g of f of x? I hope you will agree that the answer is no. So earlier tonight when we were doing multiplication, we said multiplication is commutative, meaning the order doesn't matter. 3 times 5 is the same as 5 times 3. With function composition, order does matter. So order matters with composition. So composition is not commutative, as we say. That's all that I have to say about composite functions. We'll see a lot more of these when we do something called the chain rule. And now we will move on to the most important, perhaps, type of new functions from old that we're going to see tonight, and that is called inverse functions.